Okay, here's 8.7, example 2. This one is one where the numerator, it doesn't simplify quite so nicely, so we just have to be a little bit careful. We're going to find, that's an F, it's totally an F, the Taylor series for f of x equals 1 over x squared, centered at a equals 4. Okay? So again, we're doing a funny center. In the book it tells you if the center is 0, we call it a Maclaurin series. So we're going to make our table again. We start with n, and we saw we're going to want 0 and 1 and 2 and 3, maybe 4. Who knows? We'll see how far we go. The second column is the nth derivative at x. So all we're doing is taking derivatives. Last time we went across the row first. This time let's just take derivatives and go down and see what we get. Well, if I don't take a derivative, it's x to the negative 2. Now you can write it however you want, but I think this is going to be easier moving forward, so I'll leave it like this. When I take the derivative, I'll get a negative 2x to the negative 3. In the next step, I'm going to bring down my negative 3. So that'll be negative 2 times negative 3 times x to the negative 4. So you see why keeping the 2 and the 3 are going to be helpful in this next step. That's a negative 2, a negative 3, a negative 4, x to the negative 5. Now if I was just writing out the numbers, I would have a 2 and a 6 and 24, and I might recognize that as factorial, but when I see a 2 times a 3 times a 4, it's easier to think factorials. So if you don't simplify, it's easier to see. Okay? So then we want the nth derivative at the number a. In this case, that's a 4. In that case, I'm going to start with 4 to the negative 2, which is 1 over 4 squared. I could say 16, but it kind of hides our pattern. Notice the x's will always be in the denominators because they're negative, and the others will always be in the numerators, the coefficients. So the first numerator is a negative 2 over 4 cubed. The next one is going to be positive, so I'm not going to write both negatives anymore. But that's a 2 times a 3 divided by 4 to the 4. Then a 2 and a 3 and a 4, and it's negative. 2 times 3 times 4 divided by 4 to the 5. Now, if you notice, the number on top is a factorial. So if we were to actually keep up the pattern, we would probably guess that it's going to be a positive 2, 3, 4, 5 divided by 4 to the 6. So when we were going to go all the way down to n, the nth term, the generic term, we think that it's going to line up nicely, but you have to be very careful. It's probably going to be a negative 2, and then a negative 3, and then a negative 4, and then it'll keep going. And if you look, when we did the third term, it stopped with the negative 4. So it'll stop at the negative n plus 1. Well, that didn't look very nice. And the exponent is 1 more than that. So x to the negative n plus 2. But the negatives and the pluses kind of get confusing. So let's look at it in a nicer fashion. Column doesn't line up as nicely, but that's okay. So it's alternating. So we check. Is it negative 1 to the n, or is it negative 1 to the n plus 1? Well, when we plugged in a 0, we had a positive, which means that this is the term we want. So we've got a negative 1 to the n handling our alternating. Our denominator is always over 4. When I was taking the second term, it was 4 to the 4. The third term was 4 to the 5. The fourth term was 4 to the 6. So it's always to the n plus 2. It's 2 bigger than the term we're talking about. So if we're talking about the n, it's n plus 2. The factorial is one number less than that. For 3, we had 4 factorial. For 2, we had 3 factorial. So we've got n plus 1 factorial. We need the parentheses to make sense there. So this is our numerator in the Taylor series. So if we were going to write it out, we would say that f of x is the series from n equals 0 to infinity, where this is our numerator, negative 1 to the n plus 1 factorial, over 4 to the n plus 2. That's our numerator, all over n factorial times x minus our center, in this case was a 4, to the n. We can simplify. This is a fraction and a fraction, so the 4 and the n factorial are on the same level. So that's the series from n equals 0 to infinity, negative 1 to the n plus 1 factorial, over 4 to the n plus 2 times n factorial, x minus 4 to the n. Now, since we're all wonderful mathematicians, we know that this should simplify. N plus 1 factorial is the same thing as n plus 1 times n factorial. So the n factorials cancel, and we're left with an n plus 1. So f of x, which is the function 1 over x squared, is exactly the same where it converges as the sum from n equals 0 to infinity, negative 1 to the n times n plus 1 over 4 to the n plus 2 x minus 4 to the n. So this function is the same as that series centered at 4 on its domain of convergence, which is why we learned 8.5. You could check this with the ratio test to see where it's accurate. I hope that the table format makes sense. Don't forget that this is just the numerator. You have to keep your n squared and n factorial in the denominator. A lot of people leave that off. So I hope that helped, and you have a great 2 days. Send any emails with any questions you have.